Dear students, in the second lecture on Newton's law of motion, we give absolute units of force. In FPS system, the absolute unit of force is poundal. Thus, 1 poundal is the amount of force which produces an acceleration of 1 feet per second square in a mass of 1 pound. And in FCGS system, the absolute unit of force is dyne. It is the amount of force which produces an acceleration of 1 centimeter per second square in a mass of 1 gram. And in MK system, SI system, which is Standard International System, the absolute unit of force is Newton, briefly written as capital N. It is defined as it is the amount of force which produces an acceleration of 1 meter per second square in a mass of 1 kilogram. Next, we will define weight of a body. Weight of a body is the force with which the body is attracted towards the center of the earth. If m is the mass of the body and g the acceleration due to gravity towards the center of the earth, then weight equal mass multiplied by acceleration, that is W is equal to m into g. Next is gravitational units of force. The units of force which depend upon the force of gravity are called gravitational units of force. In FPS system, the gravitational unit of force is pound weight, briefly written as LBWT, pound weight, also called weight of 1 pound. It is the amount of force with which the earth attracts a mass of 1 pound. In CGS system, the gravitational unit of force is gram weight, briefly written as GMWT. It is the amount of force with which the earth attracts a mass of 1 gram. In MK system, which is Standard International System, the gravitational unit of force is kilogram weight, briefly written as kg weight. It is the amount of force with which the earth attracts a mass of 1 kilogram. Thus we have 1 pound weight or 1 lb weight is equal to g poundals is equal to 32 poundals, because the value of g in FPS system is 32 feet per second square. 1 gram weight or 1 gm weight equal g dynes, which further equal to putting the value of g, which is 981 dynes, and 1 kilogram weight or 1 kg weight is equal to g newtons, and this can be written as 9.8 newtons. Now students, we solve examples based on Newton's laws of motion. Example 1 is find the uniform force that will move 1 kg mass from rest through 1 meter in 1 second. The solution: here mass equal 1 kg given, initial velocity given u equal 0, s distance is given 1 meter, and time is given 1 second. Let f be the acceleration, then using equation of motion s equal to ut plus half ft square, we have putting the values of s, u, t. 1 equal 0 into 1 plus half f into 1 square, which comes out to be half f, and therefore f comes out 2 meter per second square. If P be the impressed force, then P formula is P equal mf, and putting the value of m and f, m is 1 kilogram and f is 2 meter per second square. P comes out to be impressed, that is impressed force comes out to be 2 newtons. And the next example is a body of mass 25 grams is acted upon by a constant force. It acquires a velocity of 2 cm per second in 5 seconds from rest. Find how large is the force acting. The solution of this problem is, here initial velocity u is equal to 0, final velocity v equal to 2 cm per second, and time is 5 seconds. Let f be the acceleration of the body. Using v is equal to u plus ft, we have 2 equal 0 plus 5 into f implies f equal 2 by 5 centimeter per second square in magnitude. Let capital P be the force, then Newton's second law of motion formula we apply. P equal mf. Here m is 25 and f we have find out 2 by 5. On simplification we will get 10, the value of capital P impressed force as 10 dynes. Next example, a body of mass 150 kg is acted upon by a force of 5 Newton for 15 minutes. If the particle starts from rest, find its velocity at the end of this period. Solution: here m equal 150 kg and P equal 5 Newton. Using the formula P equal mf, we have 5 is equal to 150 into F, and we will find F equal 5 by 150. On simplification, we get 1 divided by 30 meter per second square. Here initial velocity u is equal to 0, t equal 15 minutes, and we will convert it into seconds, then it comes out to be 900 seconds. Now we have to find v. Using the equation of motion v equal to u plus ft, we have v initial velocity is 0 plus f we have find out 1 by 30 into the time t is 900. On simplification, we will get final velocity v is equal to 30 meter per second. Example 4. A force of 150 newtons acts on a body of mass 15 kg for 5 minutes and then ceases. What is the force required to bring the body to rest in 2 minutes? Solution: let f meter per second square be the acceleration produced by a force of 150 Newton acting on a body of mass 15 kg for 5 minutes. Then F equal force divided by mass. Force is given 150 value and mass is given 15. On simplification, we will find the value of F equal 10 meter per second square. Now initial velocity u is equal to 0. Final velocity, we suppose it is v, and time taken is 5 minutes, and if we convert into seconds is equal to 300 seconds. Thus using v is equal to u plus ft, we get v is equal to 0 plus 10 into 300, which comes out to be 3000 meter per second. Let F dash be the retarding force applied at this instant to bring the body to rest in 2 minutes, that is 120 seconds. Using v is equal to u minus f dash t, we have v 0 equal 3000 minus 120 into f dash, and implies f dash comes out to be 3000 divided by 120 is equal to 25 meter per second. Required force according to second law of Newton, P equal to mf is equal to mass into retardation. Mass is your 15 kg and you find retardation f dash is equal to 25, and if we multiply 15 into 25 it comes out to be 375 because this is force and we will measure it in Newton. Next example is a mass m kg is acted by a constant force p kg weight under which in t seconds it moves a distance x meters and acquires a velocity of b meter per second. Show that x equals gt square capital P divided by 2m is equal to v square m divided by 2gp. Solution: here force is given capital P kg weight. We will convert it into P into G newtons. When we convert kg weight into newtons, then it comes out to be P into G newtons. Let f meter per second square with the acceleration. Then P into G equal mf implies f equal P into G divided by m. Initial velocity equal 0, final velocity equal b meter per second and time equal t seconds. You will see in book the figure. Please go through your books when you learn about lecture second. In book of dynamics at page 5.6 the figure is given. We apply force P. When we apply force, the body displaces, let it displaces to x distance, and after displacement the body weight remains same m kg. Then Pg equal to mf implies f equal to Pg by m. Initial velocity is equal to 0, final velocity equal v meter per second and time equal t seconds. Using the relation equation of motion s equal to ut plus half ft square, we have here x distance displacement is x, so we replace s by x, and initial velocity is 0, so u is 0 into t plus half f, the value of f is capital P into g by m into t square is equal to gt square capital P by 2m. This result comes about x comes out gt square P by 2m. Again, using the equation of motion, v square minus u square equal to fs. We have v square minus initial velocity 0 is equal to 2f, value of f is pg by m, and s distance is displacement is x. The implies x we will find out from here b square m divided by 2gp. This is equation second. From equation first and second, the value of x from equation first is gt square p by 2m, and from second equation the same x is equal b square m divided by 2gp, which we want to derive. Next example, a bullet weighing 81 grams and moving at the rate of 200 centimeter per second is fired into a log of wood means in some dove or in some tree made of wood, into which it penetrates. It goes in the wood, it penetrates 10 centimeter. If the bullet moving with the same velocity when fired into a similar piece of wood 5 centimeter thick, that is, instead of 10 centimeter, now thickness of wood is 5 centimeter, but the speed of bullet is same. With what velocity would it emerge? We will have to find the velocity, but what velocity would it emerge? Also find the force of resistance. Wood produces resistance. Also find force of resistance, supposing it to be uniform. Now the solution here, the mass of the bullet m is equal to 81 gram, weight of the bullet 81 gram. Initial velocity bullet hit the wood is given 200 centimeter per second, and final velocity when the bullet penetrates after 10 centimeter, the bullet stops. This is the final velocity, v equal 0. Let f centimeter per second square be the acceleration, because the bullet is changing its velocity, therefore acceleration comes into play, and let f centimeter per second square be the acceleration. Using v square minus u square, this formula equal to fs, we have final velocity is 0 square minus initial velocity 200 whole square is equal to 2f, and penetration distance of bullet is 10 centimeter into 10, and this here, from here f comes out to be minus, this is a retardation, minus 2000 centimeter per second square. Why it comes retardation? Because when bullet hit the wooden wood, the velocity goes on decreasing, and so the acceleration goes on decreasing, so it is a retardation. Therefore retardation equal to 1000 centimeter per second square. The negative sign of f implies that it is retardation. Now retarding force equal mass into acceleration is equal to 81 into 2000 dynes, and after simplification is equal to 16 to 000 divided by 981 gram weight, and after simplification it comes out to be 165.1 gram weight. In this second case, Second case, the same wood but thickness is 5 centimeter. Initial velocity is the same, 200 centimeter per second. As distance, but distance is 5 centimeter instead of 10 centimeter. Here distance is 5 centimeter. And retardation is 2000 centimeter per second square. The same process, retardation, which in first it is also in second. Then v square, using the formula v square minus u square is equal to 2fs. We will find v square equal to 200 whole square minus 2 into 2000 into 5, and it comes out to be 20,000, and therefore v comes out to be 100 under 2 centimeter per second. And putting the value of under 2, which is 1.4142, multiply by 100 is equal to 141.42 centimeter per second. This is the answer. Next example is a train whose mass is 20 tons, moves at the rate of 60 miles per hour. After steam is shut off, steam, water produces steam in train. In all trains, the trains were running from steam. After steam is shut off, it is brought to rest by brakes in 500 yards. Find the retarding force when a train stops. The force is retarding. When the train starts, the force is accelerating. To find the retarding force, assuming it to be uniform. Retarding force is uniform. If it is not uniform, the train will collide. The solution is initial velocity equal 60 miles per hour. Convert it into feet per second. Then 60 into 22 by 15 is equal to 88 feet per second. Final velocity is equal to 0. Distance traveled by train is 500 yards, which is in yard. 1 yard is 3 feet. So this comes out to be 1500 feet. Using v square minus u square equal to 2fs, we have v square final velocity. Because the train stops, the final velocity is 0 whole square. The train starts with initial velocity 88 minus 88 whole square is equal to 2f, and it covers distance 1500, implies f comes out to be minus 968 by 375 feet per second square. Therefore retardation r equal 968 divided by 375 feet per second square. Given that mass equal 20 tons, if we convert into pounds, then multiply 20 by 22 to 2240 pounds. Retarding force is equal to m into r is equal to mass is 20 into 2240, and your retardation r is 968 divided by 375 poundals, and it comes out to be 20 into 2240 into 968 divided by 375 into 1 by 32 pounds weight. 1 pound weight, if we convert into poundal, is equal to 32 poundals. Then putting these values and after simplification, we get retarding force is equal to 1 and 46 by 75 tons weight. Then we will continue next lecture after that.